Now that we know how to work with inequalities, now remember that inequalities are anything that's not equal, so it's going to be a less than or a greater than or something like that. Okay, so we know how to work with those. What we're going to work on or focus on today are compound inequalities. And a compound inequality just means that you have more than one inequality in the same problem. For example, on this one here, I have x is greater than 4, or x could be less than -1. So I kind of have two options there. So to graph that, what I'm looking at is all the x's that are greater than 4. Now since it's not an or equal to, I'll put an open circle on the 4, and I want all of the x's greater than that. So that's everything this way. Or another possibility might be that the x is less than -1. So that's another open circle. And I want all the x's that are less than that. That's anything down this way. And so x can actually fall anywhere in this range here or in this range here. All right, let's try one that has an and in it instead of an or. So I want all of the x's that are greater than -3. So that's an open circle at -3, and all of the x's that are greater than that. But it also, so it's not just one or the other, but it also at the same time is going to have to be all the x's that are less than 5. So when I look at that, that's an open circle at 5, and all of the x's that are smaller than that. So that's this direction. Well, the only place that it works for both of them, because it's an and, it has to be greater than -3 and be less than 5, is going to be everything in this range right here. That's where it gets like double shaded. I got it shaded both directions. So my final answer is actually going to be everything from -3 all the way down here to 5. X could fall anywhere in between there. So that's the difference on an or and an and. An and, it has to be kind of where they overlap and they both get graphed. An or typically is going opposite directions. Okay, so let's try another one here. So solving compound inequalities with an and. So now it's not going to be as straightforward as they just hand it to me. I have to do a little bit of solving. Okay, now this is the short form for an and. Not only is my x plus 2 going to be greater than 4, my x plus 2 is also going to be less than 8. And so I can write that all in one big inequality. X plus 2 is still greater than the 4, but the x plus 2 is less than or equal to the 8. Okay, so let's get rid of that. And to solve a compound inequality, you're just trying to get the x by itself. But this inequality is almost like having two equal signs in there. So whatever you do on one side, you got to do to the other. But it really means I've got to do it here. But I also have to do it on this side, and I got to do it on this side. So I subtract the 2 in an effort to get the x by itself. So the x is by itself. But if I subtract the 2 from the x, I've got to do it on all sides of the inequality. So 8 minus 2 is 6, and 4 minus 2 is 2. Okay, so what this means is I want all of the x's that are greater than 2 or equal to. So now this one's going to be a closed dot. So I put a closed dot at the 2, and I want all the x's that are greater than or equal to that. So that'd be everything this way. But I also want all the x's that are less than or equal to 6. Okay, that's a closed dot on 6, and all the x's that are less than that. But remember, it's an and scenario, so it has to be true for both of them, which only happens where they overlap. So I want all of the x's that actually fall between 2 and 6, which kind of actually makes sense just from this right here. I want all the x's that fall between 2 and 6. Okay, why don't you try a couple here? Actually, tell you what, you try this first one and then check it, and then make sure that it's right before you try the second one. So I'm going to pause for a little bit. You pause the video, work through this one, and then turn it back on and see how you did. It's okay, I'm going to wait a long time. Go ahead and pause the video. Okay, is this what you ended up with? I tried to get my x by itself by adding the 3, but if I add it here, I've got to do it on both sides of my inequality. So I ended up with an 8 and a 1 when I did that. So I wanted all the x's that fell between 1 and 8. So I came over here and marked my 1 and my 8 and all the x's in between. Okay, look at number 4 here. You can see there's a little bit more going on. There's going to be more work involved in getting that x by itself. Just step by step, just like we've always done. It's just that now you have to do it on both sides of that inequality. Go ahead and pause the video and give this one a try. Okay, here's what I did. I subtracted the 2 first to get the 3x by itself, but I got to do it in all places. So then I had a negative 12 less than a 3x, less than or equal to a 6. And then to get this x by itself, I have to divide everything by 3. Now be careful with this division step. Remember that if you ever divide by a negative, it changes your inequality around, and it would affect both of those. You'd flip both of those. Now, I divided by a positive 3, so I didn't have to worry about that. But I do end up with a negative 4 less than x less than or equal to 2. So when I graphed it, since this one was just a regular less than, I did an open circle at negative 4. I did a closed circle at 2 because of the or equal to, and it's everything in between there. Okay, let's try some more compound inequalities, but let's practice with the or instead of an and situation. There's not really a shortcut to writing a compound inequality that has an or, like how we condense the and get rid of the word and. On an or, we just write the or. And so we treat each one of these as a separate problem. So on this first one, if I wanted to get the x by itself, I would divide both sides by 2. So x is less than or equal to 6 divided by 2 is a 3. Or, and I got to leave that or in that. Make sure you write that word so that you remember that it's an or situation. On the right side here, it looks like I got to divide by 3 to get x by itself. So then I have x is greater than 4. So to graph this, I'm looking at all the x's that are less than or equal to 3. Okay, that's a closed dot at 3, and everything less than that. And then I want all the x's greater than the 4, so that's an open circle at 4, but I want everything greater than that. Okay, these are not one of the overlap situations. I just graph both inequalities, and there it is. X can be anything on this side of 3 or on this side of the 4. Okay, so let's see if you can do that. Treat each inequality by itself, so solve this one first, then solve this one, and graph them and see what you end up with. Let's just do this first one and then check it before you jump in and do the second one. So take a minute, pause the video, and try this one on your own. Okay, let's check your work. You follow along as I talk through it here. The first thing I did on this inequality was to add the 5, trying to get the x by itself. Negative 2 plus 5 is a 3. Didn't need to do anything with my inequality, so I want all the x's greater than or equal to 3. Or, make sure you write the word or, then I have to do this one. Add the 5 to get the x by itself. So then x is going to be less than or equal to negative 1. So to graph this, I start off with this one. Well, actually, you can notice they are both or equal to's. So you can see I did closed dot for both of mine. I want the x's greater than 3, so that's where I went here. Closed dot for the or equal to. Or all the x's that are less than or equal to -1. That's this direction. So x could be anything in this range or this range. Okay, let's try one more, a little bit harder, a little bit more going on with my x. Solve each inequality individually and then graph it. Go ahead and pause the video. All right, let's see how you did. On the left inequality, first thing you got to do is add your 1 to the other side and then divide by the 4. So you should have gotten x is less than 4. Or, when you do the right one, you got to divide both sides by 8. So x is greater than or equal to 6. Nothing else to do with that, so I just continued and brought it down. All right, so to graph it, I'm looking for x's that are less than 4. So that's an open circle and everything to the left. Or x's that are greater than or equal to, close dot, 6. Everything to the right. Okay, so let's try doing this backwards. What if the graph is already there? Could you turn that in to a compound inequality? Could you write it? Okay, ideally you've caught on that your ors, now this isn't always the case, but it's going to be the case for us as we are first doing this, that or situations are going to have your arrows go in opposite directions. And if it's an and situation, which we sometimes condense into a single inequality there, but they are usually like everything in between two values. Okay, so if you look at this one, this is everything between the 0 and the 6. So to do that, instead, remember our shortcut, instead of writing the word and, we'll just stick the x in the middle. And you always, when you do these compound inequalities, they are always less thans, less than, less than. As I look at this, my left bound here is a closed dot, so I'm going to want an or equal to on that. My upper bound is an open dot, so I'll leave it a less than. Okay, so I want all the x's that are bigger, because this is bigger than 0, because 0 is my lower bound there. I can see that's where my graph ends. And then the high end, I want all the x's that stay smaller than this 6. So basically you're just putting your lower bound here and putting your upper bound up here and make these always be less than signs. And you stick your x in the middle. Okay, just a quick little thing here about some notation, just to practice this one more time. Sometimes we use the word and, but we try to go ahead and do the shortcut. So let's practice writing that shortcut for an and. I stick x in the middle. They're less than. But, you know, it kind of depends on how they choose to write it. So make sure you get this put in the right order. You want all the x's that are actually bigger than 0. So that's actually this side of it, because x is bigger than, and so I'll put a 0 there. Notice that it's an or equal to, so I'll include an or equal to on mine. On this side, you want all the x's that are smaller than 6. Okay, that's set up beautifully for the right side. All the x's smaller than, I'll put my 6 there. Okay, so sometimes you'll see the and. Just think of it like this compound inequality notation. Okay, so you try these next two. The first one's going to be the and scenario. The second one's going to be the or scenario. See if you can write your inequalities. Pause the video. Let's see how we did. Okay, so this is my and scenario that I'm actually going to write in this compound notation here. So remember the quick and easy way. You put your x in the middle, less than, My lower bound is a -8. My upper bound is a -3. Notice they were open circles, so that's why I don't have or equal to's on that. So this is all the x's that are bigger than -8, but still smaller than -3. Okay, on the second one, they go in opposite directions, so that's going to be an or scenario. So I look at this one right here. I want all the x's that are smaller, because it goes left, so I'll do a less than, -4. Notice it's not an or equal to because I had an open circle. On the right side, I want all the x's that are greater than, bigger than 2. It's a closed dot, so I put my or equal to on it. Okay, so towards the end of your assignment, they have some problems to kind of show you why you would want to write these inequalities. And so, looking at this first one, it says, part A, the directions here say, write a compound inequality to represent the indicated quality control level, and then graph the solution. Okay, so a lot of times when you're talking about a range of values, we use that as an inequality. And so it says the recommended pH level for a swimming pool is between 7.2 and 7.6. Okay, so what that means is I want my pH level, which I'll call P, I guess. Actually, they already did it for me, so I'll just look down here. I'll call it P. I need it to be between 7.2, so that's my lower bound, and 7.6, that's my upper boundary there. Put less thans, and it said it needed to be between there, and the word inclusive means that it could include that, so it could be equal to that, so that's why I have or equal to's. So anytime you see that word inclusive, that means do an or equal to on it. If I were to graph it, I want all the pH values between 7.2 and 7.6. So my pH value can fall anywhere in this range here. My swim pool should be good to go. Okay, let's try one more. We'll go ahead and do this one together. It says write the compound inequality to represent the indicated quality control level. Okay, so the recommended alkalinity level for a swimming pool is between 80 and 120 parts per million, inclusive. Okay, so I write my X first, and then I'm going to put less than. It's inclusive, so these are going to be or equal to's. And I put my lower bound, which is 80, and my upper bound is 120. So this is all the x's that are bigger than 80, but smaller than 120. So to graph that, since they are or equal to's, we'll put closed dot at 80, closed dot at 120, and I want all the values in between there. So you have a handful of these at the end of your assignment where you're just writing this compound inequality and then graphing it. All right, so your homework tonight is listed at the bottom of the screen here. Work on that. That's right out of your textbook. If you want a separate paper, you can, but it's kind of nice sometimes when they put the number line there. Either way, maybe you want to create your own number line, however you want to do that. What I'd like to do now is go ahead and let's get started on your homework kind of together here so you know what I'm looking for. So take a minute and pause the video and get your book out, turn to page 88, get your pencil ready to go, and when you're ready, start the video again. Okay, now if you're somebody that writes kind of big, then you probably are going to need to do the algebra part of this on a piece of notebook paper. If you can keep it kind of neat and small, then you can go ahead and write on this. They just didn't give us very much room to do the algebra work, and so go ahead if you need notebook paper, you know who you are, take a minute, get some notebook paper out, pause the video, I'll get started when you're ready. Okay, so let's look at this number 3. So the first thing we're going to do is we're supposed to solve it and then graph it. Okay, so we have to get the x by itself. So I have to divide by 3. This is one of those and scenarios that we wrote as a compound inequality. So you've got to divide by the 3 everywhere. So what you end up with is a negative 1 less than x less than or equal to 3. Okay, so now they've made a nice number line for you. If you're doing this on notebook paper, you can just kind of create your own. You don't have to make a full number line. Just use the numbers you know that you need. So I need to be able to get to negative 1 all the way up to 3. You maybe go 1 past that if you want, whatever. All right, and so to graph this, this is the compound one where I want all the x's that fall between negative 1 and 3. Now this is not an or equal to, so that'll be an open circle. This one is or equal to, so it's a closed circle. So closed right here, open at negative 1, and I want all the x's that fall in between there. So that would be your graph. Okay, so what I'd like you to do is go ahead and finish up working on this through number 10. So pause the video, get through some problems. When you're ready for number 11, turn the video back on. Okay, on these problems, they give us the graph. We just have to write the inequality. All right, so one of the things I'm going to write here one more time that you need to remember, if your arrows are going opposite ways, that's an or scenario. If it's something where they fall in between, that's more of an and scenario where we say x is between something and something. And we use maybe a less than or equal to or something like that. Okay, so this one on number 11 looks like they're going opposite ways. So this is going to be a big or scenario. Okay, so let's start with the left one. We want all the x's that are smaller, because it's going left, we want all the x's that are smaller than negative 2. So that's what I write. X has to be smaller than negative 2. Now notice that it's a closed dot, so I'm going to want to include an or equal to on my inequality sign. On the right side, I want all the x's that are bigger than 7. So to write that, I say all the x's that are greater than or equal to, because of the closed dot, 7. And that's it. That's all I'm doing, is turning that inequality or that graph into an inequality. Okay, you have to pay attention to, not all of them are an or situation. So make sure you look at that. Let's go ahead and look at number 12, because that might be one that's like that. So if you were going to do number 12, okay, so on this graph, because it's one of the ones that goes towards each other, this is an interval, so this is my and situation, but I'm going to write it condensed, like all of the x's that fall between, so I do a less than, less than. On the left side, it's an open circle, so I'm going to leave this, but the right side is a closed circle, so I'm going to put an or equal to on that. And so my lower bound is, and I have my sign missing there, but that's a negative 8 right there. So the lower bound is negative 8, and then my upper bound is a 1, meaning that I want all of the x's that are bigger than negative 8, but also at the same time I want them to be less than 1. So that's everything in that range. Okay, there's the inequality. Okay, so at this point you need to pause the video, work until you get ready for number 17, and then we'll chat again. So pause and get through 16. Turn it on at 17. Okay, so on this problem it says an iguana needs to live in a warm environment. The temperature in a pet iguana's cage should be between 70 and 95 degrees inclusive. Okay, so let's start with a graph of that. Everything between 70 and 95, so that's in here, 70 to 95. And remember, inclusive means or equal to, so I should put closed dots at both of those spots. So 70 to 95 inclusive. But then we also are supposed to write the inequality. So you can use whatever variable you want. Sometimes it's nice to use a variable that means something. Since this is a temperature, I'm going to use a T. You can use X if you want, that's fine. But then I want all the T's or temperatures that are less than, or equal to's because of the closed dot. Lower bound is 70, upper bound is 95. So those are all the temperatures that fall between 70 and 95. All right, so that's what they want, both a graph and an inequality. Okay, so I'm done. At this point, I want you just to go ahead and finish out the rest of your assignment. Good luck.